Okay, I'm about to try the second practice problem from the Chapter 9C3 practice exercises. This one, let's see, it starts off with a universal statement for all x if not sx and px, then qx. When you have a universally quantified statement like this, in all likelihood, I'm going to need to use, make use of some of the stuff inside here, like maybe modus ponens or whatever. I need to use this internal material, but it's all quantified. It's all got this universal quantifier out there. So oftentimes, when you're seeing something like that, you're going to want to start thinking about instantiation. Dropping off that quantifier so you can start working with it using the normal rules you already know from Chapter 8 to deal with the stuff inside here. And then again, if you need a quantified statement for your conclusion, well, you might just use some sort of generalization at the end to get back to what you need. So you drop off the quantifiers through instantiation, and then to get them back, you use generalization. But in the meantime, after you instantiate, you can use the old familiar Chapter 8 rules. So that can be quite helpful. I haven't seen anything else yet here, so I don't know what we're going to do exactly, but that's what I'm thinking just from the start. So, line 2, another universal one. For all x, then if sx, then not px. Okay. And then I'm supposed to get to, for all x, qx. Okay. So I am thinking I'm going to need, all these statements are universally quantified, and I don't have, besides like change a quantifier, that kind of thing, I don't really have rules that are going to help me here. I can't just apply modus ponens to these things or anything like that. So I'm going to want to follow that pattern I just mentioned, where I'm going to drop off these quantifiers, right? I'm going to instantiate, and then I can start working with the stuff inside here from using the old rules. And this is a universal statement as well. So I'm going to want to introduce, I'm going to use a universal generalization probably at the end. To use a universal generalization, I need to be working with free variables. What that means here is when I instantiate, I have a choice, at least when I instantiate a universal, right? I can choose a constant, like a or b or c. And since I know this is true of everything, it'll be true of any constant. Or I can use what's called a free variable. That's where I just leave a variable. And what that's really just saying is, since I know this is true of everything, it's going to be true of some particular thing, whatever that thing may be. I don't have to name it. I just leave a variable there and say, whatever thing you choose, it's going to be true of that. You can, you can use, you're actually allowed to use the same variable. You can just keep it x, and that's usually what I do because it's easiest. You could go with y or something like that. You can use a different variable if you want, but I'm just going to go with x. So I'm just going to be dropping off these quantifiers here, keeping the x's as free variables, and then if I have a free variable, I can use universal generalization. It's the only way I can use it. So that's what tells me that I want, since I have this universal statement here, since I need to get rid of these quantifiers to be able to work with the internal parts here, that tells me I want to be able to use universal generalization, which means I would need free variables here. Okay, so what can I do with what's inside here? I need to get to here. So, this is the thing about q, right? Qx. There's a qx, so I want to get to that. That's a consequent of a conditional, which suggests to me I want to use modus ponens. So how do I use modus ponens? I need to get this to look like that. Right? I need to get to the end. I need to turn this basically into the antecedent. Now here you may not immediately see how to do that. I don't know, but I've worked a few problems like this, so I start thinking, okay, this is really telling me, if you remember the truth conditions for conditionals, this is saying that either this is false, remember the conditional is true if that's false, right? This is false, or right, this is true, which is saying that not px. So either not sx or not px, if you remember the rule there is called implication. Not sx or not px, this is equivalent to that. And hey, that looks almost like that, right? With De Morgan's, I can turn with using implication on this and then De Morgan's, I can turn this into that. Now again, that may not occur to you right away. You may need to play around with it, think about replacement rules. If you're trying to rewrite things, you want to look at replacement rules to see if you can do that. So you want to just start looking at those replacement rules and thinking, how can I turn this into that if I want to use modus ponens to get to that? And that's what I'm going to do, right? So let me just start off line 3. I'm just going to drop off this quantifier. It's just instantiation, but I'm going to leave a variable, a free variable as they call it. If not Sx and Px, then Qx, right? And that is just line 1, universal instantiation. I'm going to also go ahead and just get rid of that quantifier on line 2 and just have if x, then not Px. And that's just line 2, universal instantiation. Now I want to go ahead and use the replacement rule to start rewriting this so it'll match that. Right? And again, I don't know if, how difficult that would be for you to see which rules will be helpful here, but when I'm looking at it, this already looks like I'm going to use De Morgan's to get to it. I mean, it just looks like 1/2 of a De Morgan's replacement rule if you look at those, right? So I'm starting to think of De Morgan's, to get to De Morgan's this would need to say either not Sx or not Px, and then I start thinking, okay, well, how can I get that from this? And implication, if you just look at the replacement rules, you'll see, oh, that looks like an implication. So line 5, I'm going to just go ahead and rewrite line 4, so it'll say not Sx or not Px, right? And that is just line 4 implication. And then line 6, now I can use De Morgan's on that and say, well, if one of them's got to be false and they can't both be true, so it's not the case that Sx and Px, right? And it's just De Morgan's. All right. And now I can do my modus ponens, right? Because I can say I have if not Sx and Px, then Qx. I have not Sx and Px, so I can use modus ponens to get Qx. Okay? And that's lines 3 and line 6, modus ponens. And then that's going to give me my conclusion because, again, this is a free variable. This basically just says whatever x you might choose, pick anything you like in the whole universe, it's going to be a q. It's going to be one of the q's. So that means that for all x, for everything, they all must be q's. If you can pick anything arbitrarily and it's going to be a q, then everything has to be a q. Right? And that's going to be from line 7, and this is universal generalization. And to do that kind of generalization, you need a free variable. Right? You need to know that any arbitrary thing is going to be one of those things. So that's the entire proof. Let's see if I can zoom out a little bit here, get you the whole thing. Right? Again, a little complicated. Got some replacement rules and that sort of thing. But overall, it was just a matter of sort of thinking through how am I going to get to this conclusion, which means how am I going to get to that consequent. Got to get rid of those universal quantifiers to do it, and then just rewriting things so I could do the modus ponens I was looking for. All right, hope that helped.